Hi everybody, welcome to the webinar today. I hope everyone's having a great day. We're looking forward to sharing this content with you. My name is Ian Goodridge and I'm a product marketer at Spire Global, and I'm joined today by three colleagues, one from Spire Global and the other two from Clearmetal. We're really thankful you're taking the time to review the content. As everybody gets settled in and gets online, I wanted just to take a few seconds to cover a few housekeeping items. Everyone is welcome to use the question and answer section of the poll of the GoToMeeting. And additionally, everyone's lines are on mute, so don't worry about background noise. We will be handling Q&A at the end of the presentation. Okay, we covered a basic agenda when you signed up, and we'll be covering the items that you see on your screen right now. Additional items we've added today just to, for everyone. We will be doing a couple of quick polls to capture some insights on where we want to take the content today. And additionally, we're actually going to be doing some live demos of interacting with AIS data towards the latter half of the presentation. So welcome to the team. You're talking, I'm talking, I'm Ian Goodridge, product marketing at Spire. I'm joined by Carlota and Marco and Milad. And all of us will be doing quick introductions as we get online, as we run through the content. Okay, first up, we wanted to make sure that everyone's GoToWebinar is working and everyone can kind of interact with the content. So I'm going to launch the first of our polls, and you just need to answer the question that pops up on your screen, and that will just make sure everybody knows everything's working and you can answer those questions for us. So you should see a blue box that says, is your firm currently using or considering using a supply chain visibility software provider? And we would like you to pick one of those three answers. And I'll keep this open for just a few seconds. Excellent. Okay, about half of you have voted. Keep it up. Oh, that was a good bump. Now we're at 70%. Okay, almost there. Let's get to 80%, 15 more seconds. Okay, we're going to stop there. So great, very interesting results. About 85% of you responded. That's excellent. And 30% of you are currently using supply chain visibility software. 40% are interested in providing it this year, and the remainder don't really have any plans yet, just considering. So thank you for taking the time for that.
So hi everyone, maybe we'll start with a round of introduction. So my name is Marco Gier. I am a data scientist and software engineer at Clearmetal. I've spent the last 3 years of my life working and building and designing of the Clearmetal platform, where we ingest, we clean, we enrich, we validate, and we predict supply chain data. My background is in data science, and I've worked in a predictive marketing analytics firm, and also in a fleet car sharing technology company. And
Yeah, hi everyone. My name is Milad. I've been with Clearmetal a little less than a year, focused on using machine learning and statistical analysis to build and improve our predictive intelligence that powers the Clearmetal application. Prior to Clearmetal, I was a data scientist at LinkedIn, and prior to that at Autodesk, mostly focused on the business analytics aspects.
And so to give people a little bit a background about Clearmetal, we are like a supply chain visibility platform that focuses a lot on fixing the supply chain data issues. Over the last 4 years, we witnessed a large issues of data being generated in the supply chain industry. Those issues come from data that is being missing, data that is being late, data that has been containing like wrong information, and sometimes data that is just duplicated. And we've witnessed those issues at a pretty large scale with almost every single actors in the industry. And we identify that there's a huge lack of trust in the data in the industry. This lack of trust have some side effects. People tend to don't trust the data, and that leads to inefficiencies in the business process. And Clearmetal focus a lot on trying to provide the most reliable information that you can trust and automate business processes. So to do it, we really are a data-first company. So we rely on data. We have different data providers that allow us to gather information about the supply chain. The first one, it's the EDI feed. So for people that are not familiar with EDI, EDI is the standard way of communicating and exchanging information within the supply chain. It's a protocol that has been built in the 90s and is still in place. We have a live data connection for EDI for the top 15 ocean carrier that allow us to gather real-time information about all the movement of containers and bookings and BOL around the world. We also leverage like partnership with Spire, for example, to collect independent third data source, such as AIS, which is the live position of all the vessels in the world, but we use to cross-validate and enrich the information that we get from the EDI. Also, as we've been working for the last 4 years, we have a pretty significant amount of historical events that we use to build and train a machine learning algorithm. So on top of those three pillar of data, we have an AI and machine learning layer that we use to power information inside our web app that you can see at the bottom right, and on which you can set up alerts and get a good visibility of your containers. So today we want to discuss about what is data science at Clearmetal and how do we use it to essentially improve the quality of the information in supply chain. So we recently pushed a product about imputing vessel arrival milestones that we want to discuss with you today. This product essentially consists in identifying in real time when a vessel arrives at a port and making this information available as soon as possible. During this presentation, there's three things I want to emphasize. The first one is that data science is not a single algorithm that you applied anywhere. It's really a competencies and a tool that you can use to answer specific questions that allow you to solve business case. And at Clearmetal, we are not using out-of-the-box solution that we are plugging on supply chain data. We are building proprietary algorithm to solve specific questions. The second thing is that we are data-first company. So one thing that makes us unique is that we focus a lot on applying machine learning and AI to actually clean, validate, and enrich the raw data so that we can actually increase the quality of the data to make better decisions. And finally, we work a lot in collaboration with our business partner to identify what are the biggest issues at the moment. We acknowledge the fact that data will never be perfect. There will always be data that will be lost, data that will be missing or wrong, but there's a lot of things that we can do. And so, for example, the project that we did today was triggered by a collaboration with one of our business partner. They identified that there was having issue about how the vessel arrival was reported, and this milestone was actually a pretty significant milestone in the business process, because as soon as the vessel arrived at the port, it triggered a whole chain of events, from transferring ownership of internal team about who's managing the container. It was also triggering communication with the end customer about the real-time status of the shipment. And it was also triggering some invoicing process. And so it was a key milestone for them. And when we did an analysis on this milestone, we identified pretty significant data issues in terms of latency and completeness, but Milad will go further into details. And we decided to leverage AI's position for our partnership with Spire to really increase the quality of these milestones.
Cool. Thanks, Marco. So as you can imagine, based on what Marco was talking about, something the data science team at Clearmetal is very conscious of and spends a lot of time thinking about is data quality. We're constantly analyzing and measuring the quality of the data that we receive from a variety of aspects. And I want to talk about two metrics here that are very relevant and significant to this specific use case. Looking across all the carriers around the world, for about 10% of container trips, we actually never receive an EDI message saying that a ship has arrived at a port. And for the rest of the trips, there's on average about a 36-hour delay in identifying when a ship is at berth. Again, this is based on the EDI data that we receive from all the major carriers around the world. So in other words, every shipper in the world receives an update indicating that a ship has arrived at a port about 1.5 days after it actually happens, if they get the message at all. As Marco mentioned, this delay is super important and has the potential to increase costs across many aspects of the supply chain, including things like excess derayage fees, increased costs of demurrage, higher costs of capital, and so on. This is actually a pretty complex problem to solve that the industry has struggled with for years. We knew AIS would probably be able to help us here, but the challenge from a technical perspective was really twofold. First one was, can we tell accurately that a ship has arrived at its destination and is at berth? This is important because we only want to say a ship has arrived when it has berthed at the dock and is ready to be worked on. It's important to make the distinction here between a ship that has stopped at berth versus a ship waiting to berth, because a lot of times we see a ship waiting to berth outside the port, and this can happen for a number of reasons. For example, if a specific berth location at a port is already occupied by another vessel, that vessel would have to wait its turn and then move into that location. As you can see on the screen here on the map, there are a number of yellow dots, and each of these corresponds to a ship that has stopped in the general vicinity of this port in Busan in a period of about a couple of months. Just looking at this picture, you can see that some of these stops are very close to the dock, and so they must belong to a ship that has berthed and is being worked on. And then there are other ones where they're in the middle of the water. You can definitely tell that they're not at berth yet. So the challenge here is to translate that intuition that you can see from this picture into a machine learning algorithm. The second challenge is, can we do this at scale? In other words, we're dealing with thousands of ports, terminal operators, and berth locations, and each of these ports are very much unique in how they're run, in their location, shape, size, geographical features, and the amount of traffic they see. Not to mention, ports and terminals change with time based on a multitude of reasons like macroeconomic changes, technological improvements, and so on. So based on what we've seen from other ocean visibility solutions, most just assume that if a vessel has stopped close to the latitude and longitude associated with the port, the vessel must be at berth at that port. But as I just explained, and as you can see in the picture, that's a pretty naive approach. We can't just say that if a vessel has stopped close to a port, it's at berth. If we do that, then we might interpret these waiting stops as berth stops and then inaccurately report that a vessel has arrived at its port, which is not a good outcome. We need to be a little bit smarter than that. So how did we tackle this? The first step was analyzing over 2 billion AIS messages that were received over a period of a couple months from Spire for about 10,000 container ships. We used this data to identify over 100,000 vessel stops at all container ports around the world, and those are the yellow dots that you saw on the screen before. But then something what we observed was that these yellow dots are clustered very densely at berth locations, but further away from the dock, they become less calculated and more spread out. So the idea was to find locations where multiple vessels have stopped in the same spot, or at least very, very close to each other. If multiple ships have stopped at the same location over and over again, then we can be confident that these are berth locations. So we iterated on this idea, tuning the parameters of our clustering algorithm until we arrived at a solution, and the result is what you see on the screen here as an example. Our algorithm was able to distinguish between vessel stops at berth locations, which are now the red dots on the screen and the orange circles around them on the map, and those that are waiting to berth, which are left as yellow dots. So essentially, We have been able to define a border or a geofence around the berth locations, those orange circles that allow us to detect the stops within these borders as berth stops, and anything outside of them as waiting to berth. So using this algorithm, we were able to build actually a pretty accurate map of berth locations at all container ports around the world. And as you can imagine, the downstream impact was better than, it was actually better than we thought. We were able to lower the missing milestone rate from 10% to close to 4%. And we were able to lower the latency of our vessel arrival milestone from 36 hours, which is industry average, to about 5 hours. And those are very significant improvement. And as you can imagine, they have a significant impact on our customers. Not only are we allowing them to know that their containers have arrived before the carrier does, the mapping of berths with AIS and combining them with EDI has this sort of a ripple effect on accurately predicting other near port activities like demurrage and detention, drayage, and other components that impact margins, personnel efficiency, and gross revenue. So all in all, this was a big win for us and on our customers, but obviously this is not the end of the road for us. We have a number of features we're actively working on and have in the pipeline for launch in the next few weeks that we were very excited about, and we believe will also bring tremendous value to Clearmetal customers. This is what you see on the screen here is not an exhaustive list, but there are two things I wanted to touch on among the most important features we have coming. First one, we have just launched an outbound API, which is super exciting. The idea here is that the insights and the intelligence that we were able to generate by combining EDI, AIS, and our customer data is not only accessible through the Clearmetal app, but can also be piped back into our customer systems for them to ingest and use however they want. This is something we heard from our customers that they wanted to be able to do, and we prioritized that as a feature to develop, and we're excited to launch that. And number two, we're working closely with the major carriers to ingest vessel schedules, which is essentially the planned scheduled movement for all containerless vessels around the world. We believe these schedules are going to be tremendously valuable for us in improving our predictions in the various stages of a container's journey, and is going to allow us to detect exceptions like rolls and missed transshipments much earlier in the journey, and be able to provide that signal, and for us to be able to provide that signal to our customers so they can take proactive actions on those predictions. So that's just a little peek into some of the main things the team has worked on recently and is actively working on. And that's it for us from the Clearmetal team. With that, I'm going to hand it back to Ian and Carlota, who are now going to talk a little bit more about Spire and the capabilities, hopefully.
I'm a product manager at Spire. I'm Carlota Escobar. Sorry, I didn't introduce myself before. Just wanted to give you a quick overview of who we are at Spire. We are a data and analytics company that collect data from space to try to solve, as much as we can, problems on Earth. We identify, track, and predict the movement of the world resources and the weather systems as well. So our intention is that we help businesses and governments make sure that they do smarter decisions about what to do next, which is we think is a vital capability given how quickly our world is changing. More precisely, how do we do that? We basically have a nano satellite constellation. In just 3 short years from now, from like our first launch, we have built the largest active constellation of radio frequency listening satellites. We are collecting and processing global data sets, which include AIS, specifically interesting for this case, which includes ship tracking, ADS-B, also for aircraft tracking, and GPS radio occultation, and other custom radio frequency listening products to help businesses and governments basically decide what to do next, as I mentioned before. So for this specific use case, we leveraged our product called Spire Sense. It is basically an API-based as a service. When I say as a service, it means data, software, and information as a service. And what we are offering here is a product highway to digital transformation in the maritime industry. What we intend to do here and what we are trying to achieve is to allow companies to plug and play easily, seamlessly, super fast, with the most innovative insights, not only data, to make better decisions around efficiency, cost reduction, and sustainability. We are very proud to show that we actually design, build, operate, and deliver our complete value chain. The only part of the process that we don't do is the physical rocket launch. That's something that's outsourced. But basically controlling the full vertical chain here, like, allows us to have a lot of control and precision of what type of data we want to do.
I'm going to share my screen right now and actually kind of talk a little bit about the visualizations we wanted to cover, kind of see AIS data in action. So I'm going to go ahead and share my main screen now. And what you're looking at is a view, an updated view, constantly updated view of all the vessels that we're tracking around the globe with the satellite AIS. And this particular view is actually quite interesting because it actually bins it out as you kind of move out, you know, from on the resolution, so you can kind of get a sense for you know, the volume of in certain areas, but you don't get kind of overwhelmed with looking at, you know, multiple thousands of vessels, you know, on there. What you actually can do with this is kind of zoom in, and as you come in there, it'll automatically kind of redraw the grids and the binning, and eventually you'll get to a point where it makes sense to look at individual vessels as we're tracking and things like that. So when they turn into little triangles, you're actually able to kind of click on this. So here we've got a you know, just a fishing boat off the coast here. We tracked it earlier today. Very not very old message there at all, and we collected it with a satellite. So this particular vessel is obviously too far away from land to be collected with terrestrial AIS. It's out in the open ocean, and that's where the satellite comes into it. I am going to bring up the PowerPoint now, but I'm not going to put it in present mode, just to share some of the images that are on the slide. And just to kind of cover a little bit more on the AIS overview, I did want to do that before I was cut off from the call there. So at a nutshell, AIS is obviously a radio-based radio-based message coming from onboard equipment on the vessel, and it tells us quite a lot of interesting data about the vessel. And where some of the value comes from, and I think you kind of heard that from the Clearmetal guys giving the explanation, is really when you take all those large data sets, you know, those billions of records, and do that kind of machine learning and analysis. Yes, there's a real-time component that's very interesting and useful, and can generate views such as we were just looking at a second ago. But there's a lot of value to be uncovered in those data sets. And taking a look at land-based AIS data collection, on the screen right now, you're seeing kind of a heat map of about 24 hours worth of land-based AIS. And by that, I mean terrestrial, literal, you know, receivers based on the shore that are collecting those messages. They're fed into our data system as well, because they're obviously very valuable because they handle with traffic zones very well. As you can kind of see the intensity in the north corner of Europe there. What's interesting about satellite is kind of the opposite of that, right? It really is just this global coverage of those messages. And yes, it kind of looks like there's messages all over land and things like that, but this is just basically collecting anything that's broadcasting an MMSI message. And that can include things that you wouldn't expect. Aids to navigation and other Class B devices like that are actually out there and, you know, all around the globe being collected by the satellite constellation. Kind of level set the AIS message. We have to decode the messages. They come in a format that's not readable. You have to decode the message, and then kind of to get the real value out of it, you can do some kind of cross analysis where you can take those raw data feeds and actually then you know, add other data value data sets to it. And we're going to touch on that in just a second with the demo as well. We like to talk about the kind of the impact numbers. About 90% of global trade is moving by vessels, and obviously that's what we're able to track globally and have been able to do for a couple of years. How does that data get to our customers like Clearmetal to use? Obviously, the signal is collected by the low Earth orbit satellites that Carlotta explained a moment ago. downloaded via our ground stations and then fed into our infrastructure. And this is really where we spend a lot of time delivering, high value products. We add predictive analytics to that data. We add data fusion so we can bring in other data sets. And I'll show you some of those in just a second. Okay, so I'm going to jump back into a live demo right here. I'm going to stop this view here and actually take a look at a different view, which is ArcGIS. And hopefully everyone, the screen is updated here. This is a desktop application, ArcGIS Pro. Some of you on the phone may be Esri users right now and may understand a little bit about this. And what you're looking at here is just a good example of kind of building out fusion data sets. This is connected to our Vessels API, so no different to the other web viewer you saw. You're able to interact with this data. And it's actually showing right now world ports and large ports. Obviously, the larger the dot, the larger the port. And I'm going to kind of just walk through an example here. I'm going to zoom into a port off the coast of India here. And again, you can see the vessels being kind of fed into here as a feature level within Esri. But this is where we're really kind of starting to add that value to the API. So yep, okay, there's vessels off the coast of the port here. Let's figure out a little bit more information about them. We have the standard AIS messages. We know an awful lot about the vessel, its size and things like that, as well as its latitude, longitude, and speed over ground, things like that. But what's interesting is if I click into here, I actually will get that kind of pop-up box again saying those familiar things like that. But actually what I'm able to do is if I click through the viewer here, I'm actually able to cross-reference that vessel with using its MMSI or its name or its IMO and actually collect fixture data from that vessel. So we're actually getting some insight onto what's on that boat and most importantly, where it's heading to. And the reason that's important is as we continue to grow this data set and we learn about where vessels say they're going and where they're, based on where they actually are, we're going to continue to add predictive analytics to the AIS data. You heard from Clearmetal how they were able to, to do very accurate berth identification. Well, we're looking to do the same thing with ETAs of ports and things like that to really challenge the LACAN information that's provided through the fixture data. One other interesting thing about the Esri integration is it actually gives you a chance to actually explore the 8-hour prediction. So what I'm going to do here is go off and just pick a different area to draw and kind of show you how you interact with it. And again, there's no global view on this particular view, so it doesn't show the global AIS data like it did on the web viewer. That's just because it hasn't been set up. Of course, it absolutely is possible to do that. So I'm just going to take a little look over here on the coast of the United States. And I'm going to redraw an area of interest just off the coast here. And all I have to do is literally use the ArcGIS to kind of draw a box. Again, you can do this with map view or other shapes as well. I'm just going to finish that one off. And it's actually going to go ahead and quickly go out, check with the API and say, okay, what vessels are in there? And lock them in for a kind of a constant refresh. So this could be an area of interest off a port or an area of interest if there's other shipping activity that are happening. This will go off and just run that for a second, and it's going to draw back boats and bring me back positions. Just wanted to say that it is actually currently looking at only a certain type of vessel. It's set up just to look at tankers right now. But what I'm able to do is actually click on these vessels and collect a destination or a projected route over the next 9 hours. And you can see when I clicked on this particular vessel here, it drew a blue line showing that where we believe this vessel is going to head based on all the historical insight we have on this particular boat and the particular activities of boats like this. And this is available for upwards of about 70,000 vessels that we track all the time. And we really look forward to kind of expanding this out to help customers like Clearmetal a little bit further along the line. Okay, so I'm going to pause there for just a second. And next up I'm going to zip over back to the presentation. Thank you for everybody for bearing with us with the less than optimal technical issues. So when we talk about next-gen AIS, AIS data has a lot of room to improve. And the way we look at it is there's other value sets to be added. So we're focused on couple of really critical areas. We're doing more and more investment on high traffic zones and doing more work on the satellite to improve what they're listening to and delivering. That's critical, and actually kind of one of our nice unique features is the ability for us to work with our satellites constantly and improve their software. API, we're spending a lot of time being invested in making the APIs easier. It's actually now possible for you to get a feed of your AIS data or vessels that you're interested in inside your Excel desktop. So if you're sat there and you just want to work with a spreadsheet, you don't want to worry about all the infrastructure that it takes to get that, you can just plug it straight into Excel and have rows of information coming up that are constantly being updated. We touched a little bit on the ETA and the predictive work. This is a big focus for us right now. We're really excited to spend, to help customers like Clearmetal reduce the time they spend figuring out ETA and port destinations. And then data fusion. You already showed me demoing adding fixture data to the presentation. To the data, and we're continuing to add that. And in fact, we actually do incorporate weather data into our predictions as well. Another good example of fusion. Okay, this is a video, which obviously I'm not going to play because I don't want to put it in presentation mode right now. But basically, this is just a good example from a customer that's combining VMS data, which is fishing data, fishing boat activity data, to AIS. And again, we actually have another customer that's fusing very interesting one. They're tracking under or seabed assets, be it obviously drilling activity or rigs or underground pipelines and cabling, and they're actually using Esri and our data sets to alert for any boats that are being, having a kind of an anomaly around speed that may be potentially about to drop anchor where they're not supposed to and damage, underwater assets. Really interesting use case there. And then another use case that we're really interested in exploring a little further is kind of combining our data sets with more visual data sets as well. Spire actually doesn't do imagery from its satellites. We're strictly focused on collecting radio signals, and but there's lots of other companies out there that do provide really interesting image data. So you're kind of getting this complete overview by combining a rapid imagery data, and that can include SAR as well, so synthetic aperture radar data, which can see through clouds and things like that. Combine that with AIS to kind of give you that insight. And we actually have another webinar coming up in November where we're going to be talking about using predictive analytics to task satellites to capture photographs of ships that may be turning off their AIS receivers, potentially to avoid detection. We're going to be kind of estimating where we think they're going to go and then trying to capture that activity with a satellite and then re-identify them once they've turned off their AIS responders. Okay, I'm going to go ahead and fire up another poll here. Hopefully that won't be the button that kicks me out again. But we are kind of interested kind of on what you've heard about AIS data and Spire in general. Is there any interest in kind of continuing the conversation on that? So I'll give you a few seconds for that to launch. Great, everyone's responding really well. So thank you for that. All right, about 60% of you are voted. Okay. We'll keep going, a few more seconds, 15 more seconds. All right, we're going to close that one down. Great, 85% of you responded. Thank you for that. So a lot of you are interested in learning more about AIS data. That's excellent. So I'm going to close that poll, go back to the presentation here. So that actually kind of brings us to the kind of Q&A section. We got there a little later than I hoped with the computer issues. I'm going to check on the questions right now and see what we had come in. So anybody who wants to add an additional question to the question and answer poll, feel free. It's inside the GoToWebinar control panel. But I have a couple that I'm ready to ask right now, and I'm going to ask the Clearmetal team to make sure they're on their own, online to answer. The first one is going back to the machine learning exercise. The question is, did you have any issues with the AIS data? How easy was it to work with? If I think this customer is asking if they wanted to do their own thing, like you've done.
Yeah, happy to answer that question. I don't think I wouldn't say we ran into any major issues with AIS data, like with any data source. There are we are dealing with things like, there were areas in the world where we might not see as much of a coverage, or sometimes, so for this specific application, we wanted to sort of isolate only look at container ships. And again, so that was an exercise where we had to sort of cross-reference a number of different sources to make sure that we were only looking at vessels that were considered container ships. So there was a little bit of work into making sure that we were looking at the right data set. But once we had that in place, no, I don't think there were, it was one of the cleaner data sets that we worked with, so no major issues.
Okay, great, thanks. We did have a question come in from Jeff. Actually, I can take this one. It's talking about, do we capture weather data and that supply chain folks could utilize? And actually, I might, as I'm still presenting, I may actually take a second to show another view. Let me see if I have this one coming up here. I'm going to bring up a slightly different visualization, and it's actually a really good question. So yeah, Jeff, directing the answer to you as you asked, but we are using our weather data in our predictions. Spire actually collects quite a unique data set from a process called radio occultation from the GPS satellites. And we are able to take that data and provide that to organizations that are interested in creating their own kind of global weather models. But what that actually ends up when it impacts shipping and supply chain is actually, if I turn that on for a second here, I'm going to turn on environmental layers and just turn on wind speed. You can kind of get a picture of in this visualization here of current wind speeds with graphics. It may be a little choppy on the GoToMeeting, but it is kind of a seamless circle around the hotspots of weather. And we're taking this data and using that to impact our ETA. But we have had quite a bit of interest from clients that are potentially looking at this, controlling their own data sets for their own use cases. So there's control tower kind of experiences that are very popular right now, where an organization really wants to, have total visibility into its risk and supply chain. And they are looking to combine that data as well. It does play very well with maritime, though, obviously, with course rerouting and large weather impacts to critical routes. Okay, we have a question about, does Spire have their own polygon database? And I believe that question is focused on, do we have a database that would show areas of interest, perhaps like ports, potentially? That might be the question. And the answer is we have those data sets available. We actually work on the model where we do a lot of the work to write scripting and kind of develop a model that can be shared, and you're able to contact us and we can share that kind of code with you. Obviously, you need the data to make it work. So it's kind of a, okay, here's the code, we've done the work. Okay, and there's the data, put those two together. So. And there's one more question coming in on Spire's pricing plan. That's a great question. It follows a very normal API first approach. And what that means is there are tiers based on how much data you're looking to collect. Do you need the whole world? Do you need every vessel? Do you need certain ship types? Do you need certain areas? It's just tiered from there. And that's how the pricing model works. And then additionally, there's add-ons that we can provide, and that would be an example of what I just said, regarding like algorithms we've already written and scripts and things like that. Okay, and there's one more question for the Clearmetal guys. If someone's asking if you wouldn't mind going back to kind of the roadmap areas, what's next for you? A little bit more detail on that. So I'm not sure if you wanted just to kind of add a little bit more color there, or are you happy with what you said?
Yes, to reiterate what Milad said, we essentially just launched our first outbound API, but we're going to allow our business partner to get real-time tracking and ETA for every single containers that we are tracking on our platform. We also currently said vessel schedule, so we are partnering with all the top 15 ocean carriers to get live vessel schedule update, and we are going to work pretty heavily also to update our prediction to leverage those vessel schedule and make those one more accurate and more reliable. We are also talking. We are also currently working on a sharing functionality that allow people to essentially share like any shipment status with any business partner that they are interested in. And Milad, am I missing something?
No, I mean, I would say generally, you know, we're always looking and improving our predictions and sort of notifications that we provide to our customers as soon as possible. So we're always iterating on ideas and trying to figure out how we can do that better. So, you know, whether it's pulling in new data sets or trying to look at them from a variety of different perspectives. Yeah, I would say those are the major ones that we have prioritized and we're tackling right now. So.
Great. Okay. And we had one more question come in. It was, how does Spire identify the vessel? I think the easiest way to explain that, and that part of the presentation was kind of when we were getting a little bit choppy there with the issues. But we actually listen for the MMSI message that comes from the radio transponder that's on board the vessel. And when we collect that, when we decode it, it provides enough information to identify the vessel. So that was a good question. So, okay. So I don't have any more in the Q&A panel right now. Thank you everybody who contributed. So I think we're at a good stopping point now, unless there's anybody else on the line wanted to add. If not, we're going to thank everybody for their time today and close the webinar. Milad, Marco, anything to say? Fine if you don't.
No, thank you for your time.
Great, excellent. Thank you, Carlotta.
Thank you, everybody.